Alright, we're talking about perpendicular and angle bisectors today. How can we describe the set of points equidistant from endpoints of second order side of angles? That's a quick definition. We're going to prove and apply theorems about perpendicular and angle bisectors. And we'll talk about equidistant and locus. I don't hate any of you. Dislike something. Okay. Oh, do you really? Oh, you're my favorite. All right. I have peanut butter. Oh, okay, that's fine. Anybody else need more time? You're getting there? Back? No, which one are you on? I mean, I'll come back. I went back to it. Right. We need to know this. Whenever I have a point that's the same distance from two or more objects, we call that equidistant. Look at the root word, equa. What does that remind you of? Equal, right? Equals, equilateral, equidistant, EQUI. Okay? That's the prefix. Equa. Equifax. You ever heard that? No. Watch television, right? Equifax? Okay, all right. So equa, anytime you see this little word right here, EQUI, you're probably going to be thinking the same or equal or the same amount. Okay? So equidistant. Everybody say it. Equidistant. Thanks, Tyler. Everybody else say it. Equidistant. Okay? All right. Triangle congruence theorem is going to be used to prove theorems about equidistant points. Don't worry about that so much. Okay? And then go ahead and complete this definition of locus, although I don't know how much we're going to end up using it because we don't have to worry about parabolas, but a locus is a set of points that satisfy the given condition. So how will we use locus in this case? Perpendicular bisectors are the locus of points in a plane that are equidistant from the endpoints of the second. In definition form, it doesn't make sense. Just wait till you see it when we draw it out. Okay, put a little bit of flesh to that definition. Alright, y'all ready to move on? Okay. Mad Dog, I am not waiting on you. Anybody else? All right. Let's write this out. You're gonna need to know it. Sorry, I didn't make it bigger. If perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant to the endpoints of the segment. Point is on the perpendicular bisector of a segment, and it is equidistant to the endpoints of a segment. The converse says if a point is equidistant to the endpoints of a segment, then it's on a perpendicular bisector. Okay. What does a perpendicular bisector do to a segment? You know what a perpendicular angle is? What kind of angle is a perpendicular angle? What type of angle is it for? Right angle. What does a bisector do to a segment? Cuts it in half into two congruent segments, correct? So if I take my original, I'm going to walk you through everything here. I take my original segment, AB. I cut it in half using XY. Okay? So that's all I've done right now. At A to B, cut it in half using XY. XY, because it's a right angle and it cuts it in half, serves as what we call the perpendicular bisector of AB. Look how this is symbolized here. Okay? An upside down T with a hammer. Right? That tells me that language right there. I'll read it to you. Line segment XY, perpendicular bisector of AB. That's what that means. Okay? Well, if it's the bisector, it means that A to Y is equidistant B to Y, or it's congruent. Okay? And my theorem tells me that if XY is the perpendicular bisector of AB, then the distance from X to A is congruent to the distance X to B. Okay? Converse down here that I didn't make you write down is true as well. If you start off by saying that XA and XB are congruent to each other, that means that XY must be the perpendicular bisector of AB. Anybody need this one more? Okay. All right, check it out. It wants me to find a measure of B to C. Since AB is congruent to AC, that means that this AB, AC are congruent. It has to be that A to D is the perpendicular bisector of BC. It's the perpendicular bisector. I say this until you guys fall asleep. Two important concepts that you've got to remember. Forms a right angle, cuts the line segment into two congruent angles. Okay? So there's congruency everywhere here. All right, Dylan, if D to C is 12, how much is B to D? Good. So what is the total distance from B to C? Right. That's all you got to do here, okay? Right. My original question was, to find the measure of BC. I've just got to be able to use those theorems together. Okay. Another example. Woo! Okay. If I wanted to find T to U, this ball, I'm trying to find T to U. Here's what I know. UW forms a right angle, and TB, T to B is, T to W is congruent W to B. What would we call UW in relationship to TB? What would we call it? call it the perpendicular bisector. I got to look at this diagram and recognize right angles are formed, two congruent segments exist. That would be the perpendicular bisector. What my theorem says is that if this is the perpendicular bisector, then point U is equidistant from T and B, which means that those two segments are congruent. If the segments are congruent, that means that they have to be equal. So if I want to solve for TU, I set 3x plus 9 equal to 7x minus 17. Solve for x. I get 6.5 when I solve for x. And I take 6.5 and substitute it in for x. 3 times 6.5 plus 9 gives me 28.5. Right? Okay. I also need to know what an angle bisector is or does. So please write this down with me. An angle bisector. The point is on the bisector of an angle, and it is equidistant from the sides of the angle. So, okay, if couple things to notice here. How do I know if I have an angle bisector? What does an angle bisector do to an angle? What does the bisector do? Bisector do. Cuts it in half. I'm throwing softball questions your way, and a couple people are getting highly been good this morning too. Right? It cuts it in half. So CP represents the angle bisector of APB. Okay? How do I know that it's cut the angle into two congruent angles? Looking at this diagram. How do I know that APC and EPC are equal? What on the diagram gives it away? What? Nope. Nope. Looking just at this diagram, how do I know that this angle and this angle are congruent? Nope. That's a good question. Challenge. Okay, it says it. I know that. If I gave you, no, I like this. I like this. If the only thing I gave you is that right there, how would you know that angle APC is congruent to angle BPC? Both sides have the right angle. No, I like this. Yeah, you guys are thinking through your proofs, which is good. Yes, sir. HL. Yeah, I could eventually, but we're still missing the easy first getting out of answer. I'll give it away. These two rings right there tell me that the angles are congruent. Right? All that I was looking for.
I said the angles were the same,
How do you know?
because the lines are the same.
Okay. Rings. Yeah, I was looking for rings. All right. That's how I would know. So what else do you notice about angles CA and CB?
both have a right angle.
Thank you. They have a right angle. They form a right angle. Okay. All right. Now, my theorem tells me that AC and BC are congruent to each other. Okay? All right. Let's roll through a couple of these. This isn't that hard. Find the measure of BC. C to D is 7.2. Is this an angle bisector? Yes. Means that C to B and C to D would be congruent, so it's 7.2. Okay? Ooh, this is a tough one. If EFH is 50, I'm sorry, find the measure of EFH if EFG is 50. This is a definition of angle bisector. What does an angle bisector do, Mads? What does an angle bisector do to an angle? So what's half of 50? 25. Right on. Okay. All right. I want this one to be done in 30 seconds. No, I'll give you a minute. I'll give you a minute. Given that WYZ, so this angle is 63 degrees. Okay. It says that XW is 5.7. That's 5.7. And DW is 5.7. What's the measure of X, Y, Z? There's one operation you have to do. You got a challenge. That's good, very good. Since these two angles would be congruent to each other, it means that I would take 63. You can either add it together with the other angle, or you can multiply it by 2. 126 degrees. Okay. Remember, this is an easy way to ask what does an angle bisector do. If I've got one of the smaller angles, one of the bisected angles, multiplied by 2, you get the larger angle. Which one did I give you on the other one? EFH. Find the measure of EFH if the big angle is 50 degrees. If I've got the big angle, I would divide by 2. Here, I was given the smaller angle and I asked you for the bigger angle. So I multiply by 2. Okay? Here we go. If S is equidistant from each pair of suspension lines, what do I conclude about Q to S? About ray QS, I should say. See, that's the temptation. All it tells me is that S is equidistant from those two lines. So if it's equidistant, well, it would be equal to itself. The answer they're looking for here is that it's the perpendicular bisector. Okay. Yep. That's the answer they're looking for. All right. One last thing we got to run through here. Okay. Write an equation in point slope form for the perpendicular bisector of segments with endpoints C and D. First off, I've got to know this. Okay, this is why we started with this. Perpendicular bisector is at the midpoint. If you don't have the midpoint formula down, you need to write it down now. What is my midpoint formula? You can do it x2 or x1. Okay, I'll do x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So if you get into the classwork today, and I tell you, hey, you just got to find the midpoint, you plug those numbers into your midpoint formula, and you're sleeping right now, and you need to know what the midpoint formula is, I'll say go to your notes, because it's written down in your notes. Midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay. So, to find a perpendicular bisector, find the slope. Remember, we're trying to find this point slope form, okay? To find the slope, first I got to start off by getting the midpoint. Midpoint is going to be the point that cuts it in half. Next, okay? Oh, look, there's the midpoint formula. Okay. And it gives me, so this is the example of how I could get the midpoint between, what is it? 6, -5, and 1. Okay, and the 8, -2. Finally, I would find my slope. You do not have slope form or the slope formula written down in your notes. Write it down right now. You should have it memorized. Rise over run. It's easy fun. Y2 minus Y1 over X2 minus X1. Change in Y over the change in X. Okay. Here is the key part. This is where you can't sleepwalk through me here. Cannot sleepwalk through this part. Once I found the slope, I take the reciprocal of the original slope. Okay? The reciprocal. Right? Let's think about this. Here's my coordinate plane. Let's say I had a rise over run of 2. Okay, 2 over 1. 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 That's a great job there. Okay. If I wanted to find the exact opposite slope, I would take the reciprocal. Instead of going 2 over 1, I would go what? 1 over 2. 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 Oh, I wouldn't do that at all. If I want to find the reciprocal slope of 2 over 1, I would have 1/2. Okay? But the opposite reciprocal slope would change everything from positive to negative. Okay? Everything would be changed from positive to negative. I would definitely make sure I have opposite reciprocal for perpendicular lines. So if you want to write this down, do it. The slopes of perpendicular lines are opposite reciprocals. Right? Back to my example. If it was 2 over 1, I would take the reciprocal, which would be 1/2, and make it negative. Negative 1/2. Okay? Negative 1/2. So if I think about that, that's how I get to be able to, instead of having a positive slope, which goes up to the right, I have a negative slope, which goes down. I said up to the right, yeah, down to the left, down to the right, up to the right, down to the right. Okay. Down 1 over 2, down 1 over 2, down 1 over 2. So when you write the formula, when you write your form today, remember to take your opposite reciprocal slope in order to get your perpendicular bisector. Any questions on that?